course, I'm recording the lectures. I will give you this records, or I will upload it to YouTube, maybe, for you to review the lectures. But when I have time for this. My time is full now, especially I'm a student now, okay, like you, in the Toma. I'm trying to learn Turkish language. If some of the Turkish students would like also to be my students, my teacher, so I will be their students. We can communicate, yes. It's not a shame to be a teacher and the student, okay? We have to study and learn until last day of our life, okay? So what type of features is good? How to select features? How many features also? It's important. Okay, because we have many things. For it's an attribute of the objects, yes, or the items that you need to classify or cluster it. So first of all, the feature should be ideally representative for some things about the attributes, okay, or objects, like color, like size, like, and so on. It should be represented or let's say property of the object with some data. It should be compact. Compact means it must be like compressed. It must be about size of the data about this feature could be compressed and must be memory efficient. The features here means all extra data, extra features that not needed or not necessary, or give you similar information about the different object, must not be in your data set or features about the objects. It must be computationally simple, CPU efficient also. So compact, we speak about the size of the data about feature. Computationally simple, it must be easy to represent and calculate it, calculate this data about features. Perceptual relevant, this if we want to make a classification by human, means it can be measurable by a human, but it's not necessary, I think, for computer about this perceptual relevant. This if the human tried to classify it. But also, who gives the labels? The human, yes? So if the feature cannot be classified by the human, it will be a problem for the computer, because we give label for the computer. Okay, this X category, this Y category. Okay, who will do this category and label? Who? The expert human, yes? The expert human. Our image. Who will say that this image means cancer? Allah person. Yes. who will say it's negative, not cancer? A specialist, expert person. How he classify it? Some fields have some dark area here. So it's perceptual relevant for the human. So it can be relevant and can be used to classify the item. Okay, features could be any data about the item, like if we speak about shapes or items in around us, physical items, shape, the color, the size, and so on. If we speak about image for some objects, could be or it is inside the image, it will give you some data about the objects. We will take examples about it. At the end, I told you, all this data about the features will be represented in the computer as feature or features vector. Okay, like what? For example, here we have three features. Feature X1 or F1, doesn't matter the name, X1, X2, X3. For example, the shape, how many sides it have, the size, the color. Let me this item and see how to represent it. Okay, we have three size or two size, medium or large and small. So we could say large is 2, small is 1. So imagine that this element is X. And we want to represent it depending on its features. We have three features, X1, X2, X3. So we have 1, 2, 3 elements in the vector. For example, first one is the shape. Shape depends on how many sides. So how many sides we have here? 1, 2, 3. So X1, which is feature 1, is the size, it's equal 3. Then, or the shape, sorry, the shape. The size, we have two sizes, small and large. Depend on the training set, this one will be large, so X2 will be, if I will give it 1, for example. Okay, so this X2, which is the size. The color, we have two colors. For example, blue and yellow. For example, if blue, we will give 1. If yellow, we will give 2. So this one yellow. So third feature, which is the color, will be 2. So what's this X at the end? If we speak about the 3 direction and we want to represent vector with the 3, so at the end. So X will be a point that represent this object in the coordination system. So we have 3D coordination system because we have 3 features, X1, X2, X3. So let's see, X1 we have 3. So 1, 2, 3. So it's here, X1. X2 we have 2. So X2 we have 1, 2. So it will be here. Okay. we still have another dimension, which is x3, which is 2, for example, 1, 2. So it will be something like this. At the end, it will be in this area. So from the origin point here, it's the value or point of x. Let's name it x xa or something, because we already have different x in the other example. So this is the point. We have x3 with x2, x1, so it will come here. This is a 3D system. As a human, we can imagine 2D, 3D, but as computer, you can use many dimension, okay? At the end, the features will be as feature vector, and any vector in the same number. So 4 vector with 4 elements, use 4D coordination system, means it's point in the 4D coordination system. I'd say how many data for any point in the coordination system? It's depend on how many dimension. If we have 2 dimension, like what we was doing or we were doing in the school, so we have x and y, yes, or x1 and x2, 2 dimensions. So any point will have 2 data, x and y. If we speak about the 3 dimension, then we have any point in the coordination system will have 3 different data, which is x, y, and z, for example. If we have 4-dimension system, then any point in the 4-dimension system will have 4 different data. For example, x1, x2, x3, x4. So this number of features, the dimensions here or the data inside the vector, how many different features we will use. Okay, here another example for 2-dimension. If we speak about the shape and the size, so about shape, we have 2 different shapes. If we have 3 sides, it's a triangle. If we have 0 side, then it's, for example, circle. So if we have 4 sides, then we have rectangle or something like this. So we have x1, which is the shape. We have 0, 1, 2, and 0, 1, 2, and 3, and 4. So if it's 3, we have the triangle. If it's 4, then we have the rectangle. If it's, or the diamond. If it's 0, we have the circle. Then about size, okay, we have small, large, larger, and so on. We could have 2 categories, 3 categories, depend on how we will categorize our size here. So depend on the value of the size, 0, 1, 2, 3, 4, for example, here, the size 1, 2, 2.5, 3, 3.5, 4, and so on. So you will have different representation here, depend on these 2 features. 2 features means 2 dimension. 3 features means 3 dimension, and so on. Okay. So a simple classifier in pattern recognition work like this. We have the raw data. Then from the raw data, we have to extract the feature. So we have the, for each object, we have the features, for example, X1, X2, until how many features we need. Then the classifier will classify this object. So we have object X, for example, then we will get it for the feature extractor. It will extract the feature from this image or from this data. Then it will classify it into categories, for example, class 1, class 2, and so on. Of course, this is a simple one. We could have some pre-processing here. We could have some post-processing. We could have also the pre-classifier, which is the evaluation, and so on. We mentioned all this. Okay. Example. Sorting the fish. Imagine that we have a factor or a factory that make packaging, fish packaging, and sell this packaging. Okay, so the fisherman gets a fish factor, and the factor will put each fish in a box. Okay, imagine that we have only two types of fish, salmon and sea bass. Okay, you know sea bass? Yes, it's a delicious fish. But of course, salmon, it's more expensive. Yes, more expensive than sea bass. So we need to imagine that this factory, it's working automatically. So we bought just the fish and, for example, take it by some belts, and it will pass through camera. For example, we have camera like this here, and this camera will see the fish and classify it and put it automatically inside boxes. Okay, sea bass fish will be put in box and have labeled sea bass, and salmon, same issue. And it will be sold for the people. To do this, we should have camera, and this camera will be connected to classifier, a system to classify this fish. Then the system will have images for the fish and have to take decision to send it to the left side, for example, to be put in sea bass box, or to the right to put it inside box for salmon. Okay, how to do this? How to do this? Anyone have idea? Okay, we should have. We should have classifier algorithm. Yes, this algorithm first, we have camera here over the belt. You know the belt that move, and the fish will move over it. And the camera will take picture for this fish. Then we have pre-processing. First, pre-processing. What's a pre-processing? That separates the fish from any other noise or part from the picture. Then this picture we will extract some data from this picture, the picture of the fish. This data we call it what? Features, yes? For example, the size of the fish, the lightness, is it the bright lightness or dark or what? The lightness of the fish. Could be the weight of the fish, could be the shape. Is it flat or is it wide? Is it okay? Number of the fins for the fish, shape of the fins. You know the fins of the fish? Okay, I'm not good in drawing. Let me identify it here because this is the fins. Okay, and here in the top we have the fins. The shape of the tail. We could have many features. Okay. So first, to take decision, we should identify which features we will use. Like as I told you, the length, the width, the width, okay, number and shapes of fins, tail shape, and so on. When we have this type of systems, we could have many problems, like the lighting condition. If we have too many lights, the picture could be not okay. If we have could have some reflections and so on, more noise. If we have too few lights, we could have many darkness part from the in the picture. So the position of the fish could be direct, could be flipped, could be in the okay, in the direct position, come in what we call it not direct one, and so on. We could have some noise in the camera, so we need to do some pre-processing for the image. This first, after capture the image, then we need to isolate the fish, then take the measurement for the features, and then make the decision. Making the decision also, it's another issue. Okay. Too few features means the decision will be very difficult in some cases. For example, if we take only the links as a feature to select the fish, we will ask the experts, yes? The experts will say that, for example, in most of the cases, we have the sea bass fish longer than the salmon. So if we use only this feature, any long fish will be sea bass. Is it always correct? No, not always correct. We could have some sea bass fish that it's very short or short. Okay. So could be here not enough. Maybe the width with the links could make it more accurate. Maybe if we take the lightness, for example, is it bright or not? Okay, it will make it more accurate. Okay, this means let's take all the features that we can use, as much features as we can. Is it correct? No. No, not overfitting. Here's the calculation time and so on will cause a problem. So the efficiency of the classification will not be good. You need more calculation time. Another issue, we could have some conflicts in the features. Okay? Some features will be very close from other features. Some features will change the decision to be wrong. Okay? And so on. For example, the length and the width. Okay? Here could have some conflict. Okay, we know that longer means it have more weight and so on. So some features cannot come together because it may conflict in the decision and so on. So we have to select the appropriate number of features and the appropriate features. Of course, we need the experts to help us in this matter. Okay. In the ideal state, space means space of fish means all the fish we have, for example, sea bass and salmon. The ideal that there is no common features between salmon and sea bass, but it's not correct in our real life. Okay, all things, for example, from 2 until centimeter. All this is ideal. In the real life, the salmon and sea bass have some common features. So if we represent the features, for example, here we have two features. We can see the feature, this two-dimension, by the way. It's like this. Okay, for this feature in the salmon, we have this data, for example. Okay, this, for example, the links or something like this. For the sea bass, we have this one. So it's come like this, decrease, and we have something like this. So as you can see, what we have some common data here. We should do something like this. Look here for this feature. We have some points that the high data will be for the sea bass, the low data will be for what? The salmon. And after this point, the high data will be for the salmon and the low data will be for the sea bass. We name this point what? Through or threshold point. So we have to select this threshold point. Before it, we have meaning for the feature, the data about the feature, and after it, we have different meaning. We should know where the points, maybe one, maybe more than one threshold points. So usually for the features like this, for example, here's the links and how many fish we have for each length. If you see a fisherman with of the sea bass, it's have lengths more than the salmon. But when you collect some data for the training set, you will see that, for example, when we have 0 to 5 and 0 to 10 until for example, 11 centimeter, you will find that most of the fish will be salmon. be sea bass. This means for the small lengths here, we almost have this fish is salmon, not sea bass. For the lengths more than 11, almost we have the fish that with lengths 20, for example, or 19 or something like this, it's almost will be sea bass, not salmon. Look, it's probability. Most of the classification depend on the probability. That's why next lecture we will speak about probability. Okay, so this means it's not accurate 100%. Okay, we need maybe more features to be more accurate until specific number of features, then the curve become low again. So we need to identify how many features we need. Too many features, it's not good. Too low number of features or too little features, also it's not good. Same issue if we have another example here. So what we name this point that the data will be reflect in another way, we name it threshold point. Okay, we have to select these points. We have to calculate it and know these points, because before this point we have classification. After this point we have different classification. For example, it's 11 here. So any fish less than 11, and we take only the lengths, we will classify it as 7. Any fish, its length more than 11, and we have only one feature, the length, we will classify it as sea bass. Of course, we need more features to be more specific. Okay, for example, the average of lightness. What's the lightness of the fish? Is it bright or not? We will see that if the lightness here less than 5, okay, less than 5, it's almost salmon. If it's the lightness, we make like, okay, give numbers for the lightness. Dark, it's 0, less dark, it's 1, and so on until the high lightness, okay? If it's more than 5, so the point of the threshold here, it's 5, for example, almost 5.5. So more than 5.5, this means the high lightness will be sea bass almost, and so on. This is only one feature, which is the lightness, and this another one feature, which is the length. If we take the two features together, the length and the brightness, okay, this means if it's a small fish, but the brightness also little, so it becomes more accurate that it's salmon, okay? But if we see that the brightness high, but the fish it's small, then we have to calculate the probability, what's the percent of lightness and length. Then we will not say directly it's salmon. It could be sea bass, depend on the lightness here. So when we take the second feature, it's become more accurate, and so on. But as I said, too many features, it's not always good. It could be less efficient because computational time. It could have conflict between the features. So it will be less accurate. We have another issue when we classify the cost of error. You have this fish, okay? And we know that, or we don't know that this fish is salmon or sea bass. The system will classify it. And the system sees that the probability 50%, it's salmon, 50% it's sea bass. But the system have to take decision in this case, depend on the cost of the error. For example, if we know that the customer will be very sad and will be will have objection about if he buys salmon and opens the box and find in the box that it's sea bass. Of course, because salmon is more expensive. I buy box for salmon, then open it, I found what? Sea bass. I will not be happy. Then you will lose your customer. So the cost will be expensive here if the system not sure to classify this fish as sea bass and salmon, and the system classify it as salmon and put it in salmon box, the cost will be expensive for the company because you will lose some customers here. But we know that if we put salmon fish in the sea bass box, the customer, your customer, you spend, for example, 200 lira to buy the fish as sea bass, but you find it a salmon that could be for 500 or 600 lira. You will be sad, you will be angry. No, you will be happy, except if you don't like salmon, yes? So, as a company in this case, you will train the classifier to classify a 50-50% fish as salmon or sea bass. Sea bass. Why? Because the cost of losing the customer here will be low. If you have this fish and you classify it as sea bass and it was salmon, the customer will be happy almost. But if you did the opposite, if you classify this, it's a sea bass fish, and you classify it as salmon, you will lose the customer. The customer will not be happy. So if you are not sure, put it as sea bass, not as salmon. So the cost here will be less. So error of the cost, it's also important for classification here. Okay, if we have multiple features, we mention it. You will put it as a feature vector. Okay. When we have multiple features, for example, 2 features, you will see it in the scatter plot like this. So you have to decide where's the place or the line to classify this object. You have to take action. We have many ways to classify it. For example, as line here to take most of the object for the sea bass here and most of the object for salmon, but you will see that you have some salmon here and you have some sea bass here. Of course, if you have more features until specific number of features, you will have more accurate way. This way, it's like a line decision, or we name it decision boundary as line. You could take this decision boundary as curve, okay? But what's the problem here? It's not efficient. It's become complex boundary, and the calculation will be very difficult to do it. In some cases, you can take it as a curve, okay, to take as much as possible number of CBAS and as much as possible number of Solomon. But you will have also specific error in the classification, depend on if you select the accurate number of features and the accurate way of classification and criteria or not. Okay, that's all for today. We finished. Some classes we will finish like this a little bit. Some classes we will take the full time, depend on the subject. If the subject have many calculations, the 3 hours could be not enough also. Before we finish, I have to take the attendance again. Yes, I know.